This is lesson number 3.3 in our Introductory to Algebra book. I should explain that at Shasta, the 6th grade teachers, we combine lesson number 3.3 and 3.4 into one lesson. We find that that works fine and saves us a little bit of time. So notes are 2 pages on this lesson, and it will appear as you move on as if we have skipped 3.4. We do not. We just combine these 2 lessons and call it 3.3. So anyway, the combined title then is Solving Addition and Subtraction Equations. All right. 3.3 in our text is solving addition equations, and 3.4 is solving subtraction equations. But we have found that students can handle being taught addition and subtraction equations together as one lesson just fine. So that's why we do that. In my class, this page is 76. And your warm-ups are, this is one of the few times when you get permission from me to do the work in your head. The instructions are: solve using guess, check, and revise method. All right, and I'm going to show you on the first one what that means. All right, so number 1 is y plus 3 equals 9. Okay, well, what do you think the value of 9 is? You've been doing problems like this since you were in the 2nd grade, only usually they would show you something like a box where we're now showing you a variable, and you could figure out moving backwards. We're going to be calling that inverse operations. So let's see, 9 minus 3 is 6. So I'm pretty sure that 6 plus 3 equals 9. And I'm proving it by saying 6 plus 3 is 9, and my equal sign, and 9. Oh yes, 9 equals 9, and so I was right. 6 is the variable y. If I was wrong, then I'd have to make that's where the revise comes in. I'd have to make another shot at seeing what it is, all right? So, number 2 is, now you do the rest. I got a variety of operations to work with. 17 minus m equals 2. Guess and check, all right? Number 4, not 4, 3. Number 3 is 11p equals 77. Number 4. B over 2 equals 14. And number 5, D plus 1.2 equals 5.7. All right, so warm up your brain with those, and when you are done, be ready to write your I can statement. All right, I can solve equations. I can solve equations involving addition and subtraction. All right, that's what we're going to learn to do. This is a fun lesson. It's one of my favorites. It really is getting into the foundation of introductory algebra in in the first concepts of teaching you how to actually solve an equation, solve for the variables, all right? And a fun story goes with it, and it's a good time. I know, I sound very nerdy right now, but I think it's a lot of fun, this lesson. Okay, we've got just one piece of notes to glue in, vocabulary, and in its usual upper left corner spot. So let's glue it down. Tiny tadpoles for our glue. And put it in the corner. Press. All right. Vocabulary for this lesson. Vocabulary for this lesson. All right, the first one is inverse operations. In general, it's not really a literal definition, but in general, we think of the word inverse as meaning opposite, okay? So the definition for an inverse operation is an operation operations that undo each other, or what we usually think of as the opposite operations. So down here it says the inverse operation of addition is subtraction. Okay? The inverse operation of multiplication is division, and you likely already know that. Okay? The opposite of addition is subtraction. The opposite of subtraction is addition. The opposite of multiplication is division. The opposite of division is multiplication. Right? You've learned that years ago, and that's going to be very key in understanding and how we solve equations. The other thing that's important, and this is not going to really make sense to you yet, but we're going to highlight it and show you what this means. If an equation has a number being added to the variable on one side, I'll add in, you must subtract the number from both sides of the equation to perform the inverse operation. Here's what I want you to highlight, okay? Both sides of the equation. All right, this is very important. And like I said, I know it doesn't make sense to you right now, but I'm going to show it to you momentarily. All right. And last, it is important that you show your work as problems get more complex as you get into higher level mathematics. You hear me say this all the time. It's going to seem a little bit silly, the detail I'm asking you to be exact about, but I'm doing it because this is training wheels time. We're doing problems where you can just look at it and automatically in your head, most likely, know what the answer is. But soon that will not be true. And so I'm training you now a very specific way. You must show your work. And I'm doing that because you will be required to show your work as these equations get more complicated, as we move on in the 6th grade and all the way into, believe me, college math. When I was doing college math, it was still the same way we had to show our math is the baby steps that I'm showing you now. So it may seem like work that is unnecessary to you because of the simplicity of the problems that you're doing right now. But trust me, it's a training tool, and soon I think you'll see why. So I'm putting a red star here because this is so important. And now we get to kind of draw some little pictures here. And those of you who are in my class, you know I have 0 art skills. And I made up this little illustration to show the importance of why you do an operation to one side exactly as you do to the other side of an equation. And I'm pretty dang proud of it because it looks pretty good, and I am not good at this kind of stuff, you guys know. All right, so I'll slowly try and walk you guys through how to draw this, just in case you are just like me. So right about here, oh, it looks like I'm about to lose my lead on this one. I'm using my black pencil. I'm drawing a circle right there with a tiny little notch up on top of it. All right. Now, about a 1/2 inch long. I'm drawing a straight line out to this side and a straight line out to the other side. All right, about a 1/2 inch. Okay, now off the ends of each of these straight lines, oh, yeah, I knew I was about to lose it. All right, hold on a second. See what I got. Nope, not yet. Ah, come on. Oh, I think I've got a lead stuck in here. Hold tight a second. I'm going to pause. Okay, got my pencil sharpening tragedy solved here, I think. Oh, it feels loose still. All right, here we go. So I'm making a triangle here out on the end. And I'm making another triangle on the other side. We're making a scale to show balance. All right. And then for its stand, I'm going to draw a black line down to here. Like that. Okay? There's our scale. Now, this scale has marbles on it that I'm going to draw with my light blue, light green, and orange. Okay? So, my light blue marble is sitting right here. And my light green marble right here. And my orange marble balanced on top. Okay? And as you can see, this scale is in balance, so I must have the same thing on the other side. My light blue marble, my light green marble, and my orange marble. All right? All right. Now, because on each side I have exactly the same thing, that means this scale is equal. It is in balance. Okay? All right, that's our first one. Now we're going to draw a second scale. And I'm going to start with a circle right about here with a little notch on the top. And I'm going to have, this time, my 1/2 inch line, that's a little more than a 1/2 inch line, going at a diagonal down that way. And on the same plane, diagonal up that way, like that, okay, or about that, okay, as long as it's in a continual diagonal, you know, something like that, all right, to show the unevenness. And as before, I've got my little balance triangle here, and one here, and the stand is going down to here. All right. Now, this time I have my blue marble and my green marble, but I took the orange marble off. It's sitting down here. But on the other side, I have my blue marble and my green marble and my orange marble, all still on the balance. Okay, so now what's on the scale, 2 marbles and 3 marbles on this side, they are no longer equal. They are not in balance. Okay? All right, now, how can I make these in balance again? And the answer is not to put this back on. All right? I'll show you. So, down here, we're going to make our, oh, this is about to break again, isn't it? Make our little circle with the notch on it. And we're going to make, like the first one, we're going to make a scale that is in balance. And we've got our triangle scales. Okay. Well, it doesn't look quite level, does it? Sorry. But it is. We're just going to, if I can even it up by the looks of it. There we go. Oh, there. All right, so I have a blue one here and a green one here. And remember, I had taken the orange one off. All right? Well, it is in balance now because on this side, I have a blue one here and a green one here. And on this side, I have also taken the orange one off. All right? So now, everything is in balance again. Equal again. All right? So I started off with the 3 marbles here and the 3 marbles here. That was that meant my scale was equal on each side. It was in balance. But when I took the orange marble off on this side and did not remove the orange marble from this side, it was no longer equal. So it was no longer in balance. I want it to be balanced and without having to put the orange one back on. So what I did is I took the orange one off the other side. That made everything equal. That made everything balanced. Now, what is this all trying to show you? It's trying to show you that when we are dealing with equations, if we make a change to one side, we must make the same change to the other side, because an equation means that it has to be equal. The expression on one side of the equal sign has to always be equal to the expression on the other side of the equal sign, and it will be as long as whatever we do on one side, we do to the other. Exactly. All right? So that's our illustration of that concept, and then we'll make it, we'll put it into words over here. Okay? So here's what we're going to write. What, and I'm doing it with my red pencil. It's that important. What you do to one side, you must, I'm going to take my light blue pencil and it is that important, okay? You must do to the other side. What you do to one side, you must do to the other side. It's so important, I'm gonna start. And then I'm going to take my green highlighter and put a little arrow up to this illustration. That's what we're talking about, okay? So that's the whole concept that is being discussed right here in your vocabulary. If an equation has a number being added to the variable, you must subtract the number from both sides of the equation to perform the inverse operation. Now, I'm going to show you in numbers what that looks like in a minute. So that's page 1 of lesson 3.3, 3.4 notes. And we have a second page, and I'm going to go on to that now. Okay, so this is the second page of our notes, and that's on page 77 in my class. All right, this is a full page of notes, guys. Get ready. And so we're going to write right up here, up in the margin area. All right, so I'm going to tell you a little secret about variables. All right, you may not know, okay? We're going to write about it right up here. Variables are loners. Variables want nothing more than to just be alone. They are straight up introverts. Nothing wrong with that. Variables are loners. Their only goal in life is to be alone. Their only goal in life is to be alone. That's what they like best. All right? Variables. They want to be alone always. So our job is to move all other terms all other terms out of the variable's house. Okay? They don't want any roommates. They don't want anybody in their house. They want to be alone. Variables. And so that is our job, to get them alone. We like our variables. And if being alone makes them happy and comfortable, then that's what we're going to do. All right? Variables. Our job. Get them alone in their house. Here's what that looks like. Example number 1. Let's see, do I have them there? Yeah, okay. Example number 1. X plus 4 equals 11. All right? Now, we're ultimately trying to figure out what the value of X is. But to do that, what do we know about variables? They want to be alone. So we've got to get that variable alone, which means the first thing I'm going to do is build my fence. All right? Okay, this is the variable's house. This is his neighbor's house. All right? The variable has this 4 in his house, and he wants the 4 gone. So how can we do that? How can we get rid of that 4? Well, this is where the inverse operations comes in. I see that there's a plus sign right in front of the 4. You know, that could mean positive, that could mean addition. But one thing I know for sure, inverse operations tells me that if I subtract 4 from here, what do I get? 4 minus 4 is 0. That would make the 4 gone. So I subtract 4, and now the 4 has been evicted, gone. And X is in its house all by itself, just like it likes to be. But the 4, when he gets evicted from X's house, he tends to want to go over to the neighbor's house. And we got to take care of that too. So what's 11 minus 4? It is 7. This is the part where what we were talking about on our notes right here, what you do to one side, you must do to the other, right? So if I have to subtract 4 from this side of the equation, I must subtract 4 from that side of the equation. And once I have done that, I can determine what is the value of 7. I don't know, or I'm sorry, what is the value of X, which is 7. I don't know what the value of our variable is until the variable is all alone on its side of the equation. So, since we got rid of the 4 term, then that left us with X. And then once we did the same thing to the other side that we did to this side, we know what the value of X is. And that's how we do that. All right. So let's just kind of finish our little story about our little loner variables here, and we'll circle it, and that'll just kind of give you an easy way to remember what the steps are we're doing here. So what is X saying right here? He's saying, get out of my house. 4. All right. Oh, and get out of my neighbor's house too. All right. I don't know what 4 did, but whatever 4 did, X is not happy about it and wants it gone. All right. So that's what we did. We helped X out. We evicted 4, got him gone, and so now X is so happy. Alone. Just the way I like it. We solved this equation, X equals 7. All right, that's how it's done. Okay, so that's our story we tell ourselves. Our variable wants to be alone, and any other term in its house, our job is to evict it. But what you do to one side, you must do to the other. And that gets us the solution to our equation. Okay? All right, so fun little story. And let's see how it works in example 2. All right, so number 2. The problem is 23 plus m equals 39. Okay, well, let's build our fence. Good fences make good neighbors. Okay, and yes, you are to do this exactly the way I'm showing you with this little t-bar down straight through the equal sign so we can see this is an expression on this side, this is an expression on this side, and we must at all times keep the two in balance, equal. All right? Okay, so what's M saying? Get 23 out of my house. I want to be alone. So 23, even though I don't see an addition sign in front of it, if there isn't a symbol in front of the number, then I know it's a positive number. It's a plus number, right? And so my operation is still to subtract, to get rid of it. 23 minus 23 is 0, correct? And so that means we evicted 23. It's gone. Keep the equal signs lined up. M is now in its house, all nice and happy, all alone. But what we do to one side, we must do to the other. So now we have to subtract 23 from the other side. 9 minus 3 is 6. 3 minus 2 is 1. So I'm saying M equals 16. Now, on your worksheet and on all of your work, it will tell you to solve the equation and to check your solution. And here's what that looks like. I have solved this, and I think M equals 16, but I need to prove that. And the way I do it is to rewrite this expression exactly like it's written, only now I'm going to plug in 16 for M and check to see if they actually are equal. It's like the evaluate process that we did in lesson 3.3. All right? Okay, so 23 plus, insert 16 for M, 16 equals 39. All right? Well, let's get my equal sign in 39 here. All right? All right, so 6 plus 3 is 9. 1 plus 2 is 3. 39 equals 39. Yes, it does. Check mark right there means my solution is verified. It checks out. All right? So I was right. And the great thing about being able to check your solution like this is you'll never have a wrong answer on your worksheets or on your tests. Because if you make a mistake here, it's going to pop up over here. Something's not going to seem right. You're going to be trying to do your math here and something's not matching up and you can't figure out why. It's most likely because you made a mistake over here somewhere. And that's great. Then you can go back and find it. It's usually something pretty simple. All right, so we checked our solution. We're set there. All right, problem number 3. Example number 3. All right, 9.4 equals y plus 5.1. All right, and I'm going to build my fence. And I'm going to find my variable. Oh, there it is, y. Y does not want 5 1/10 in its house. We need to get rid of it. So I see an addition symbol here in front of the 5.1. To make this a 0, to evict 5.1, I must subtract it. So now if I subtract 5 1/10, that becomes 0, evicted. And my variable y is happy in his house all by himself, just the way he likes to be. But what we do to one side, we must do to the other. So I have to subtract 5 1/10 from this side also. 4 minus 1 is 3. 9 minus 5 is 4. And now I have a solution that y equals 4.3, 4 3/10. Right? All right, well, I think so, but I need to prove it. I need to check my solution. So I'm going to rewrite this equation exactly as I see it, plugging in my value for y. So 9.4 equals y equals 4.3, 4 3/10, I think, plus 5 1/10. All right, copy down my equal sign, keeping it lined up with this side of my equation, and then I do the math. All right, so 1 plus 3 is 4. Keep the decimal in its place. 5 plus 4 is 9, and it looks like I've got 9 4/10 equals 9 4/10, which is true. Check, my solution was correct. Okay? All right, let's do another example. Example number 4. Example number 4 is n minus 8 equals 21. Okay? Well, I'm going to build my fence for my variable. My variable likes a fence around his yard. All right, my variable n wants to be alone, but this minus 8 is in his house. What's the inverse operation of subtraction? It's addition. So to get 8 out, I've got to add it. Negative 8 plus 8 gives me 0. That's the inverse operation. So I've evicted 8. That leaves n by itself in his house, just the way he wants to be. But what I do to one side, I have to do to the other. So if I added 8 over here, then I have to add 8 over here as well. So 8 plus 1 is 9. 2 plus 0 is 2. I've got 29. So I think n is equal to 29. But I've got to check my work. So I rewrite this equation plugging in 29 for n. So I start the equation with 29, that's n, minus 8 equals 21. Keep the equal signs lined up and bring down that 21. Now, 9 minus 8 is 1. 2 minus 0 is 2. 21 equals 21. Check, my solution checks out. True. All right? Okay, one last example. And we've got number 5. All right, on number 5, we have 143 equals x minus 71. All right? All right, let's build the fence for our variable. Okay? X has got this minus 71 hanging out in his house. He wants him gone. It's our job to get him gone. I see a subtraction sign there, so my inverse operation is addition. Add 71 evicts that 71. And now X gets to be in his house all by himself. He doesn't want 71 as a roommate. He eats all of X's yogurt. All right, so if we add the 71 here, that means we have to add the 71 over here. What we do to one side, we must do to the other. So 3 plus 1 is 4. 7 plus 4 is 11. Carry the 1, and that leaves me with 2. All right? So I think x equals 214. But I need to check that. So I rewrite this equation, plugging in 214 for x. Oops. Oh, no, that's not right. Here we go. Okay, so 143 equals, plug in 214 for x, minus 71. All right, keep the equal signs lined up and bring down that 143. Now let's do the math. 4 minus 1 is 3. 21 minus 7 is 14. 143 equals 143. Check. That is absolutely true. So x does equal 214. All right? That's how we solve addition and subtraction equations. Solve for the solution and check our answer. So let's move on to some practice problems and see if you're ready for the exit ticket. Okay, here are the practice problems for lesson 3.3 and 3.4. Remember, we've combined those two lessons into one that we just called 3.3. Solve each equation and check your solution. So you're going to solve it, draw your little T fence first and solve it. And make sure that out to the side you're checking your solution just like you did in your notes. All right, so here's the first three problems, and I'll pause here. And here's problems 4 and 5. And now we'll work through how we do these problems. All right? Okay, so first one is y plus 7 equals 15. Okay, so we are going to solve for the variable. We start by building the little fence here, and we see that this is y's house, but 7 is in his house. We need to get rid of him. The opposite operation from addition is subtraction. So 7 minus 7 creates 0. That means it's no longer there, and y is now in his house all by himself. But what we do to one side, we must do to the other. So if we subtracted 7 here, we have to subtract 7 here also. And 15 minus 7 is 8. So y equals 8. Or so we think. We need to check our work. So we rewrite this equation, plugging in 8 for the variable. So 8 plus 7 equals 15. Keep the equal sign lined up and bring down that 15. What's 8 plus 7? It's 15. 15 equals 15. Check our solution is true. All right? Okay, number 2. 26 equals p plus 5. Well, let's draw our fence. A little upside down T for our fence. There's a 5 in the variable p's house. We need to evict that 5. It's a plus 5, so if we subtract 5, that creates 0. Evicted. Now our variable is all by itself, just like it's happy to be. But what we do to one side, we subtracted 5, we must do to the other. 6 minus 5 is 1. 2 minus 0 is 2. So I think 21 equals p. But we have to check. Oh, let me circle that as my solution. Hopefully I didn't make any mistakes, but I need to prove that. So I rewrite this equation, plugging in 21 for the variable p. 26 equals 21 plus 5. Okay? Keep your equal signs lined up. Bring down the 26. 1 plus 5 is 6. 2 plus 0 is 2. So 26 equals 26. Yes, it does. It checks out. That is the solution. 21 is the solution to our equation. All right, number 4. Number 4, I have 2 and 4/10 plus 8 equals 5 and 2/10. Build our fence. A is in his house. Oh, not alone. And he very much wants to be alone. So we need to get rid of this 2 and 4/10. Now remember, I don't see an addition sign in front of it, but if there is a minus sign in front of it, which would in this case mean negative, then I automatically know that it is to be assumed positive. Because if I subtract 2 and 4/10 from 2 and 4/10, I know I get what? 0. So evicted, no more roommate for variable A. But what I do to one side, I must do to the other, so I have to subtract 2 and 4/10 here as well. So I can't subtract 4 from 2, I need to borrow. But I can subtract 4 from 12, and that gives me 8. Keep your decimals lined up. 4 minus 2 is 2. So I think A is equal to 2 and 8/10. But I need to check my solution, and I do that by rewriting this equation, plugging in 2.8 for A. So 2.4, I need to stop saying that. 2 and 4/10 plus 2 and 8/10 equals 5 and 2/10. Keep your equal signs lined up and bring down the 5 and 2/10. Now let's do our math on this side. 8 plus 4 is 12. Carry the 1. Keep your decimals lined up. 2 plus 2 is 4, plus 1 is 5. All right? And if you have trouble doing this horizontally like I am, you can always just scratch out to the side a 2.4 plus 2.8 vertically, so you can keep your decimals lined up and see what's happening. And if your skills are kind of weak in dealing with decimals, that's probably a good idea. Well, 5 2/10 does equal 5 2/10, so check my solution checked out. All right, number 4. Build our fence for our equation. This nice little T here. All right, so here's my variable y. A -3 is hanging out in his house, and he's had it. Get rid of 3. Get him out of my house. Well, opposite operation is addition, so I know I've made that 0, evicted that -3. My y is nice and alone, just like he wants to be, but what I do to one side, I must do to the other. So I've got to add 3 over here because I added 3 over there. 4 plus 3 is 7. Bring down the 1. I think y equals 17. But I need to check my solution. So I'm going to rewrite this, plugging in 17 for y. 17 minus 3 equals 14. Keep my equal sign lined up and bring down that 14, and then do my math on this side. 7 minus 3 is 4. Bring down the 1. 14 equals 14. Yes, it does. Check. My solution checks out. All right? Okay, last one, number 5. M minus 6.5 equals 2. All right? So, first step, don't freak out about the fraction. Steps are the same. Build a fence. M's got this big old 6.5 hanging out in his house. Wants them gone. Opposite. Inverse operation of subtraction is addition. So we're going to get 6.5 out of M's house. Evicted. Bring down M all alone. But what we do to one side, we must do to the other. All right? And 6 plus 2 is 8 and 1/2. So I think 8 equals, or M equals 8 and 1/2. But I have to prove it, so I'm going to rewrite this expression plugging in 8 1/2 for M. So 8 and 1/2 minus 6 and 1/2 equals 2. All right? Keep your equal signs lined up. Okay? 8 minus 6 is 2. 1/2 minus 1/2 is nothing, so they canceled out. 2 equals 2. Yes, it does. Check. My solution was true. All right? So that's our practice problems. Let's take a quick look at our worksheet for this lesson. So our worksheet is a combination, shortened up combination of what you would see in 3.3 and 3.4. So the first part is using the inverse operations on addition equations, and check your solution, every single one. And then the second part is using the inverse operation on subtraction problems and checking your solution. All right, so just like we did in the notes, you've got examples for both types of problems. And then finally, there are 2 exit tickets here. Let's see if I can show them side by side without moving my focus. Can I? No, not quite. All right, out we go. As far as it'll let me go. Sorry about that. Oh, I can overlap them. Okay, here we go. All right, so there is 3.3, and there is 3.4. Can you see the other one? No. All right, then we'll do it this way. Jeez. All right, 3.3. Pause if you need to. I don't give answers or instructions on these. This is extra practice, or your teacher may use it in another way. And then here is 3.4. Okay, so that's lesson 3.3, as we call it. It's a combination of 3.3 and 3.4 from the Introduction to Algebra book. Remember, the only way to learn math is to do math, and mistakes are proof that you are learning.